Hi, this is Mr. H, and this is the review for the triangle quiz coming up. So I'm going to go through each problem, make sure you know how to do this by yourself. The review itself is not worth any points, so just it's for your own practice, but you want to do as many times as it takes to be able to do them on your own with no help. All right. These formulas will be available to you on the quiz as well, so that's so you know what you're given. And you're going to be graded primarily on, of course, accuracy, but also showing your work and showing your thinking. So even though you can use calculators, right, you still have to show all your thinking, right? So calculator is not a shortcut to do less, work. It's just a way to get the complicated answers and save some time. All right, so let me go through each one of these and skip ahead to the problem that you need help on most, and just go through each one until you are prepared. So first we have a triangle, right triangle, it says right here, which is important because that lets us know what tools we're allowed to use. So with right triangles, you can use all the SOHCAHTOA Pythagorean theorem, right? So that will save some time, right? So if I label this, and each one of these I'm going to label carefully. We got a right triangle. Let's get this a little bigger. Right, and we got B is going to be 50. Right, A is going to be 37 degrees, 17 minutes. Okay, and it does say to round sides to the nearest tenth and angles to the nearest minute. Okay, so let's start by solving everything. Okay, so let's start by finding angle B, right? So we know that these two angles are going to be complements of one another. They add up to 90 degrees. So to find a measure of angle B, right, measure of angle B will equal 90 degrees minus this 37 degrees, 17 minutes, right? Now you might recall, to do the subtraction, we convert 90 degrees to 89 degrees and 60 minutes. It's kind of like borrowing. We're borrowing a degree, turning it into 60 minutes, because they are equivalent. So if I write it this way, right, then I can do 60 minus 17 and get 43 minutes. And 89 minus 37 gives me 52. All right, so we know that this is 52 minutes. 52 degrees and 43 minutes. All right, and we can start finding the missing sides. Right, now we have a right triangle, so you have some options. You might look at this and say, well, I have B angle B, and side B. So I could use law of sines and get what the side A is right here. Right, that's a possibility, but because it's a right triangle, I don't need to use law of sines. So what I'm going to do instead is just use my SOHCAHTOA. So that was step 1. Do step 2 in green. I can use, let's say, this angle A, right, and do opposite over adjacent, right? That would be tangent. So I can just say, let's see here, the tangent of 37 degrees, 17 minutes is going to be equal to the opposite over adjacent. Right, so I just really need to multiply both sides by 50, right? And it's a shorter calculation than law of sines. Not that the law of sines would give you a different answer, it's just a little bit shorter. We need to convert this before we're doing calculations to a decimal. So I need to do 50 times tangent of 37 point, right? And then the 17 minutes. Remember, all you do is just divide that by 60. So my calculator, let's do 17 divided by 60. It gives me 0.3 if I round it to the nearest tenth. That equals A, and then I just have to put in my calculator 50 times tangent of 37.3, and I get 38.3 38.1. So this is 38.1. Now I have one more step. I need to find out what side C equals, right? So I have some options as well. I can do some more trig. I can do like A over C would be opposite over hypotenuse. That would be sine. I can do Pythagorean theorem, 50 squared plus 38.1 squared equals C squared. So again, you have multiple options. It'll give you slightly different rounded answers, so if yours don't come out exactly the same as mine, that's totally fine. Alright, but let's go with, let's say, about just Pythagorean theorem. C squared will equal 50 squared plus 38.1 squared. Of course, all I need to do is square root both sides. C will be approximately, I'll just put that whole thing in the calculator, 50 squared plus 38.1 squared and I get 62.9. So I got 62.9. And I've solved for all the missing values. I found C, I found A, and I found B. Now this is the type of work that you will want to have for your own quiz. You can see I have 3 different distinct areas of my work that show the 3 different, problems that I solved to get the answer. So notice how each one of these has like measure of angle B, and it has the answer, right? It has A equals this, it has C is approximately this. I guess I should put approximate on here as well, because it's a rounded answer, right? So you want to make sure your work is clear, right? Not just random things all over the place, and try to do it in, like my first step was right here, my second step, my third step, so it's logically top to bottom and left to right. That is also helpful. Let's repeat on number 2. Very similar, just we're giving 2 sides. All right, we're giving 2 sides here. So we can call this A, B, and C. That's 90-degree angle once again. So side B will be right here, that's 3. And side A is 7. And we need to find everything else. So once again, I'm going to use some trig right here, and I can use define A. I can do opposite over adjacent. Once again, that's tangent. So we'll do tangent of A will equal, what is it, 7 over 3? Rise over run, right? Now that means if tangent of A equals this, then the measure of angle A, since my answer is an angle, I know I have to do the arc tangent, right? That's how you know when to use this, if your answer is an angle. And it'll be approximately equal to arc tangent 7 over 3. 66.8. So what we just found is basically if we have a rise over run of 7 over 3, that makes this a 66.8 degree angle. All right, and it does say round to the nearest minute, so we do need to convert this to 66 degrees. And the 0.8, how many minutes is that? Basically, what's 80% of 1 hour of 60 minutes? So on my calculator, what I do is I subtract off the whole number. In this case, it's 66. All right, so minus 66. And then I can multiply the decimal part by 60 times 60. I get 48 minutes. So So that's 66 degrees and 48 minutes. There we go. So that's part 1. Found A. And then I can do part 2, right, and find B. Now you can do the tangent once again. I can do this time, it's going to be opposite over adjacent, 7 over 3. So basically the same exact work, but flipping these two. Or I could just subtract this from the 89 degrees and 60 minutes. So you have options, right? So your work may not match exactly. I'm just going to go through and do, since I have the work already, I'm just going to match it and change it to tangent of B. Of course, this is going to be 3 over 7. The opposite is now 3. The adjacent is now 7. Right? And the work will be identical. The measure of angle B will be the arctan tangent of 3 over 7, which is approximately equal to 23.2. Right? And that's going to be equal to 23 degrees. Right? And we'll have, what, 12 minutes, 0.2. So if I do this minus 23 and times 60, you got about 12 minutes. Which makes sense, because it matches with here, these two. Since I have 48 minutes, I knew this had to come out to 12 in order for these two to add up to 90 degrees. So you could always do a check just to make sure. So we have 23 degrees, 12 minutes, and now we have that. And lastly, I'm going to find angle, side C. Right? I need to find side C. And I can just use Pythagorean theorem, or I can do more trig, totally up to you. I'm going to go through and do Pythagorean theorem. So C squared will equal 7 squared plus 3 squared. And then, of course, I'll take the square root of both sides. And C will be approximately the square root of 7 squared plus 3 squared. So is root 58, 7.6. Alright, and I have solved the triangle. Okay. So these are lighter problems because they're right triangles. You notice how I did not use law of sines or cosines here. You can. They're longer equations, so it makes the problem longer. And if you're taking a timed test or quiz, you want to, probably go with the most efficient method, right? All right, let's go down to the next one, which is now oblique triangles, right? So now we have non-right triangles. We cannot use Pythagorean theorem. We cannot use SOHCAHTOA, right? We have to rely on our new tools, the law of sines and law of cosines. Okay. Let's label this. And angle C is like 100 degrees, so I'm going to make this C because that's a little bit bigger than the other one. So these are A and these are B. Obviously your diagrams don't have to match exactly. Let's see, so we have 29 degrees for B. Good. And side B, the opposite side here, is 27, length of 27. Alright, so I'm going to round each side to the nearest tenth and angles to the nearest minute. So we're going to stick with degrees minutes for our final answers. Alright, so let's first do the missing angle. Because I have two angles, I just have to subtract from 180. So the measure of angle A is going to equal 180 minus 27. Nope, that's not right. Minus 100 minus 29. Yeah. Right, and then that will equal, let's see here, 180 minus 29. minus 100. We'll get 51 degrees exactly. There we go. So that's one part. And then let's go to, okay, I can find, using law of sines, right? I have an angle, or angle side angle thing going on here. So recall, if you have an angle side angle, whenever you have two angles, angle side angle or angle side, that's a good cue to use law of sines. To use law of sines, you also have to have an angle and its side. So on this particular problem, I have angle B and side B, right? So that means I can use law of sines using these values. So I'm going to do angle B, sine of 29, over side B, 27. And I can choose either one. I can find A first or C first. There's not a correct way to do it. I'm going to go ahead and do, let's say, C. All right, so I'll have sine of 100 over side C. All right, so cross multiply. The values that do not have variables, that would be this diagonal right here, that diagonal. So I'll have 27 times sine of 100 all over the remaining part, which is sine of 29. Alright, I'm going to put that whole thing in the calculator. 27 sine 100 over sine 29. We got 54.8. Now, of course, if you get some weird answers, double check your calculator, make sure it's in degree mode, but probably should be by now, because we've been doing nothing but degrees lately. And we have 0.8 again, so we have to convert this to degrees minutes, so 54.8, which we already kind of figured out. So if you kind of want to use over here, 0.8 was 48 minutes, right? So you can reuse that, or you can redo the calculation. But 80% of an hour isn't going to change from problem to problem. We got 48 minutes. Oh no, I'm wrong. This is not a degree. That's correct. Okay, yeah, this is the final answer. We're doing a side. We're not doing an angle. I just got excited. So we have 54.8 for our side C. There we go. All right, so there's the work for the second part, and then I got to do one more and find the missing side. Now I can't use Pythagorean theorem, not a right triangle, so I basically just have to do law of sines all over again. I could do law of cosines if I really wanted to, but that law of sines is shorter, so I'm going to use that. Now you have a choice. Should I use like sine of 100 over 54.8, right, as my angle side pair that I have, or should I stick to doing angle B and side B? And the correct one would be to stick to B, because these are actually equal, right? B actually is equal to 27, whereas C is 54.8, right? You'll get basically the same answer, but mathematically, if we have a choice between using a equal, exact measurement of 27, which is equal to 27, or using an approximate measurement like this one, let's go with the exact measurement, right? So we have the sine of 29 over 27, and I'm trying to find side A. Okay, so I'm going to say that's going to be equal to sine of 51 Alright, and much like the last one, A will equal the diagonal 27 times sine 51 all over sine of 29. And that will be approximately, let's see, 27 sine 51 over sine 29. 43.3. So this side is 43.3. Alright, and I've solved the oblique triangle. I have all 6 measurements now. Alright, let's keep on going. We got number 4. More practice of the same thing. This time we have all sides. We only have sides on this particular problem. It's a little smaller. There we go. So let's call this A, B, and C. And then side A will be 14. Side B is 19. Side C is 8. So since I don't have any angles given to me, law of sines is definitely out, right? That relies on having an angle and a side pair. So we must use law of cosines, at least to get the initial angle. And you can choose to get any angle you want. It's totally up to you, right? So I'm going to go with, let's do angle A. Right? So we're going to use this formula right here. Plug in A, B, and C, and A and C here, and find the missing angle. Right? It's important to remember that if you're finding angle A, that this is the A as well. Right? These always match on the ends. So whatever side you're using here, you have to use that angle. Alright, so if I want to do angle A, that means I'm going to start with 14 squared. Right? And that's going to equal the other two sides, 8 squared. Was it plus 19? Yeah, plus 19 squared. And then minus 2 times 8 times 19 times the cosine of A. Right? And now I have to do all the solving to figure out what that actually equals. So my first step is going to be subtract these two. Right? That'll equal negative 2 times 8 times 19. Right? And then get the cosine by itself. I'm going to divide both sides by exactly that. And that's what this will be equal to cosine of A. So my last step is going to do the arc cosine of both sides, and that will give me what this equals. And so I'll have the arc cosine of this whole thing, minus 8 squared, 19 squared, all over 2 times 8, 2 times 19. Now equal the measurement of angle A. And then we just punch this in the calculator. Arc cosine, arc cosine fraction 14 squared minus 8 squared minus 19 squared times negative 2 times 8 times 19. I get 41.4 degrees. That's approximately. And 0.1 degrees. All right. How many minutes is that? So multiply it by 60 and you get 6. So we have an answer of 41 degrees and 6 minutes. So I've got my first angle. There we go. Now I need to repeat this, right? I need to repeat this to find another angle. I have a choice. I can do another law of cosines and just do the same thing but switch the numbers around so I have a different angle, right? So I can go to, let's say, C, right, and just make this side angle C, and then I'd switch the 14 and the 8 because I have to have the 8 on the outside instead of the 14. Or you could do law of sines. So if you prefer law of sines, I now have, right, I have a side and an angle pair, so I could use those. Right, so it's totally up to you. Personally, I think the law of sines is a little shorter, right, a little less intensive, so I'm going to go with that. I'm going to do these two. Now I want to use the decimal point here, right? So I need to use the 41.1 degrees. So I have sine of 41.1 degrees over 14. And I'm finding angle C, so I'm going to use 8. So sine of angle C over 8. And so we have sine of C will equal 8 times the sine of 41.1, the diagonal with no variable, right, divided by the remaining part, 14. Right, which means the measure of angle C will equal the arc sine of this whole thing. So remember your last step when you're using calculator and doing calculator work, the last thing, or the second to last thing you write is exactly what goes in the calculator. Right? So this whole part you want to have written, and you want to have what it equals to as well. So all this whole step here needs to be written so you can confirm, your calculations later. So we have arc sine fraction 8 sine 41.1 all over 14. And we get 22.1. So we have 22.1, and we got to make that minutes, so we'll have 22, and since this is 0.1, I already know it's 6 minutes. So let's see here, degrees and 6 minutes. There we go. And for the third angle, I can just subtract 180. You could go through and do a whole nother law of sines, right, and do all this work, but these still add up to 180 degrees, so I can just do that. So the measure of angle B will be 180 minus our other two, so we're going to minus 41.1 and 22.1. 180 minus 41.1 minus 22.1. Yeah, 116.8. So, 116.8, and convert that. It's going to be 116 degrees and 48 minutes. Alright, good. And we have solved everything that was missing, which was the 3 angles. Again, my work is all shown, very clear to see what I solved for in each problem. Everything that I put in the calculator is the step before the answer, so if I wanted to verify your work, I can just punch this in and know exactly where you got your answer from. Alright, let's keep on going. Down to 5. So we have given values of 85. So let's make this A, and this is 85 degrees. And we have side A as well, which is 15. Just those two. And side B, I'll make this right here, 25. That makes that B and that C. All right, now you'll notice that this is a side-side angle, right, which is really important. Side-side angle. Right? So we saw in this case, if you have side-side angle, right, or if you want to look at it as angle side-side, right, that you can end up with a no solution or a two solution because of this orientation. Okay? So we can use the law of sines here, but we have to be careful and check. So we'll go through that. So we have a side and an angle pair. So I'm going to do sine of, I'm trying to find measure of angle B, so I'm going to do sine of 85 over 15. That should equal sine of B over 25. Okay? So sine of B will equal, let's see, 25 times sine of 85 all over 15, which means the measure of angle B, so my answer is an angle, right? I know I have to use arcsine of this whole thing. Technically, we're taking the arcsine of both sides, and the arcsine and sine cancel out, and then we have it on the right side only. Alright, all over 15. So it's going to be approximately equal to this whole thing. So we got arcsine fraction 25 sine 85 on top with 15 on the bottom. And we get a domain error. Okay, so why is this happening? Okay, so let's look closely at just what the numbers equal inside. Let's take off the arcsine and look at what that number comes out to be. All right, 85 over 15. So you see you get 1.7. Now you recall on a unit circle, right, if we looked at a unit circle, that sine, the lowest sine could be would be -1 down here, right? The y coordinate down here, this is 0, -1, and this is 0, +1. Right? Now, each of those decimals between -1 and +1 had some angle associated with it. But 1.7, it doesn't make sense because this is a unit circle. The biggest you can have is a 1. The smallest answer you can have is -1. So because this decimal is bigger than 1, that's why it is no solution. It's impossible. Now, geometrically, what that means is that it is impossible to actually make a triangle with an angle of 85 and two sides of 25 and 15. If you actually try to construct it, it would be physically impossible to create. So that's why we have no solution, is because no such triangle exists. Alright, good. Let's look at here. We got number 6. Let's label this A up here. Let's make that the 115 since it's the bigger one. And we have sides 15 and 10. Right, that would make this angle B, and this would make angle C. So I have a side angle side, right, which means I have to do cosine. Right? If I have two sides in an angle, that's a law of cosines. So that's what I'm going to start off with first. And once again, you get to pick which angle you want to find, C or B first. It doesn't matter. We can also find side A. Like, yeah, there's lots of options here. So I'm going to find, let's say, side A. Alright. So for law of cosines, I'm going to have A squared. Right? And it'll be equal to 15 squared plus 10 squared minus 15 times 10. And that'll be times cosine of 115. And you can see why I chose to solve for A is because I have that angle here. Alright, so now I just need to pump this whole thing into the calculator. Take the square root of both sides, of course. So, square root of 15 squared, was it plus? Yeah, plus 10 squared. Minus 2 times 15 times 10 times the cosine of 115 degrees. So I get 21.3. Alright, so we got 21.3 for A. So I have all three sides, and now I need to find two missing angles. So your choice, you could do a law of cosines again, right? Now that I have 15 and 21.3, and I can use find angle C using 10. You could do a law of sines, right, which is a little bit shorter. That's probably what I'm going to do. Right. So I got a angle A and side A pair, so I can use that with 10 in the law of sines. So we have sine of 115 over 21.3, now equal sine of C over 10. Alright, so we have sine of C will equal 10 times the sine of 115 all over 21.3, which means the measure of angle C will equal the arc sine of that whole fraction. Uh, 21.3. Alright, so we got 25.2. Degrees, which is going to be 25 degrees, 20% of an hour. You can say, let's see, minus the 25 times the 60. We'll have about 11 minutes. Okay, so we have 25 degrees, 11 minutes for C. And then I just need to find the measure of angle B, and I'm going to do that just by subtracting from 180. Right, that's the fastest possible way. So measure of angle B will equal 180 minus my two other angles, which were 115 that was given to us, and then minus the 25.2 that we just found. Alright, so we have 180 minus 115 minus 25.2. So we get 39.8. degrees, which is 39 degrees, 8. And 0.8 minutes, I think that was 48. Let's double check. Minus 39. 80% of an hour would be 48 minutes. Alright, so our last angle here is 39 degrees and 48 minutes. And I've solved all the missing values. Alright, let's flip it over and do the backside. So we have, let's call this A, and this will be side A of 12. and then we have side B, or angle B right here, and we'll call this 30, and angle A is 21 degrees. So once again, we have a side angle, right? So we have to watch out for other possibilities than just having one answer. All right, so let's go ahead and solve the first part and see what we get. We have an angle side pair, right? So we can do law of sines. And we're trying to hope to find what measure of angle B is right here. So we have sine of 21 over 12, and that will equal, let's see here, sine of B over 30. Alright, so that means sine of B will equal 30 times sine of 21, the diagonal, all divided by 12. So measure of angle B will equal the arc sine of this value Alright, and that comes out to approximately 63.6. Okay, so we have to double check this. The last time this occurred with a side-side angle, we got an undefined, a domain error, so we finished. But now we actually have an angle, so we have to double check and do the test. All right, so recall that we need to find the supplement of this, right, and add that to the original value. Okay, so this is the formula, part 2 here. So I need to find the supplement, right, of 63.6, add that to 21, and I need to, that's the original, and I have to see how that compares to 180. Right? Is it greater than or less than? Is what I'm looking for. If it's less than, there's 2 solutions. Right, so supplement of 63.6. So I'm going to do 180 minus 63.6. That's 116.4. Add 21. Right, and then how does that compare? So plus 21, it's 137. Calculator back up there. There we go. 137.4, which is definitely less than 180, and because it's less than, right there, that means we have 2 solutions. Okay. 2 possibilities here for angle B. Okay. So possibility 1 is that this angle is 63.6 degrees. Right? Possibility 2 is that the angle is 116.4, the supplement of it. Okay? So if I have another triangle here, and what that means geometrically is that this 12 can be drawn here, or this could be 12 as well, right? So either way, it's just swinging and facing the other direction. So this is my other possibility, right? And that's why this is 116.4. So I'm going to call this B2, and this is 116.4. We'll call this one B1. Alright, so we have 2 different triangles to really solve. Now, The second triangle does have the same given values, right? This is still 21, this is still 30, and this is still 12. So for each one of these, we really just need to find, what would that be? On here, we just need to find angle C and side C. And same thing over here. This would be angle C, and this would be side C. All right, and we can call these 1 and 2, just so we don't get things mixed up. So basically, at this point, it's just doing the same thing we did on other problems. So let's see here. Let's do the angles. So C1. All we have to do is subtract from 180 the 21, right, and the 63.6. 180 minus 21 minus 63.6. Yeah, 95.4. Degrees, and I think we're still sticking with the minutes here, so that'd be 95 degrees and 0.4, I think would be 24, right? Double check. Yeah, 24 minutes. All right. That, and now I have to find C1, which I can use law of sines or law of cosines if I wanted to, but law of sines is a little faster, so I'm going to do C1. Let's see here, how am I write this? So we'll have, I'm going to use my given A's here. Those are more exact than my approximated 63.6. So I'm going to do sine of 21 over 12, and that will equal sine of 95.4 over C1. So C1 will equal 12 times sine 95.4 divided by sine of 21. That's better. Okay. $33.3. That's more reasonable. So approximately 33.3. All right. Approximately. And let's see, anything else we need to do here? We could make this into degrees minutes, so 0.6 times that's going to be 36. Yeah, 36 minutes, so 63 degrees. That's going to be equal to 63 degrees and 36 minutes. Alright, so I found the missing values for the first triangle. Just repeat for the second triangle. Right? And I'm going to do the same process. Probably subtract from 180 and then do law of sines again. So, orange. And let's do this time the measure of angle C2. Right, will equal 180 minus 116.4 minus 21. We got 180 minus 116.4 minus 21. So we got 42.6. 2.6 degrees. And that's going to be the same as 42 degrees and 36 minutes. All right. And then lastly, we need to find side C2. So let's go with blue. So we got side C2. we're going to use, like on the last one, we're going to use side A here. So we'll have sine of 21 over 12 equals sine of 42.6 over C2. And this time I'm not going to make the same mistake. So we'll have C2 equals sine of 42.6 all over sine of 21. Okay, and 22.7. Approximately 22.7. All right, so that gives us all those values for each triangle, both cases. Now for your quiz, I'll let you in on an inside secret if you're listening to this, that I'm not going to have you solve both triangles on the actual quiz. I'm going to just have you identify if there's 1, 0, or 2 solutions. But you're not going to have to solve and do the full thing for both triangles. Okay? So I'll make things a little bit shorter, a little bit easier. All right, let's keep on going down to the word problems. All right, so right here, oh, these are just more practice. Okay, so we'll solve for the oblique triangles. So let's get the given values in there. So let's see, let's call this one A, B, and C. So angle C would be 43 degrees. Side A would be 10 centimeters, and then we have what else? We have angle B 78 degrees, and we're finding the area, right? So we need to do some base times height, basically, right? So a couple ways of doing this, but basically we're just using that 1/2 base times height. But because of the type of triangles we're working with, we have to do a little trig as well. So let's start just by getting our formula written out. 1/2 base times the height. And notice on here that our base is going to be 10 because we have that length. So base doesn't necessarily have to be on the bottom, right? It's just we have a side. Like if you want to rotate this and put 10 on the bottom, you can. But our base in this case is going to be 10. And now our, oh, A, that should be H. Our height, that's what we have to solve for. That's what's different about these problems, is that we're not given what this height is. In this case, it would be this would be the H. So we have to do a little solving, right? And remember, the height is always a perpendicular line. So I know this is a right triangle. So I can do one of two things, right? If I find what this side is, I can use a little trig with 43 and do opposite over this hypotenuse for this triangle, right? Or I can find out what this length is, and I can do the same thing, but with 78. But either way, I need to find the length of one of these two, and it doesn't matter which. Okay? So we have to do that first, then we can figure out and solve for H, by doing a little trig and plug it back in. So I have to do a separate part of the problem. Let's see how I want to do this. Yeah, I'll do, let's say, I want to find B. Right? So I have to ask myself how I'm going to use my laws to figure this out, and it looks like I don't have enough information to do law of sines, right? Because I need an angle and side pair here. So that's probably what I want to go with, or I could use No, I have to do law of sines. Yeah, so I need to find out what this angle is, right? That way I have an angle A and a side A to work with in the law of sines. So I need to figure this out first. So let's do measure of angle A equal 180 minus 43 minus 78. So we got 59 degrees. So we need that first. That's 59 degrees exactly. All right, now I can do a law of sines, right? And with 78, and that will give me what B equals. So I can do law of sines of sine of 59 over 10 will equal sine of 78 over B. Alright, so B equals 10 times sine of 78 over sine 59. Gives us an approximate value of sine 59. 11.4. Alright, so we got B is about 11.4. Alright, so now I have this triangle right here. Right? And I have an angle, and my H is the opposite, and my hypotenuse of, let's just go like this so we can see what I'm working with here. Right, so I can do opposite over hypotenuse from 43. So it's going to be sine, right? Sine of 43 equals opposite, which is the height, over my hypotenuse, 11.4 that I just found. So my height is simply 11.4 times the sine of 43. So 11.4 sine 43. And that's 7.8. So finally we have a height of 7.8. Now I go back to my original formula here, 1/2 base times height, and plug it in. So we have a half of 10, which is 5, and then 5 times, let's see here, 5 times 7.8 gives us 39. Okay, and then of course check for units. We're dealing with centimeters, so this would be 39 square centimeters. So quite a little bit of work here. We had to find out the missing angle, we had to find a side, and then use that side with sine to find the height, and then plug height into the area formula. So quite a few steps on here. Make sure you practice that a few times to make sure you get all the little steps in there. Alright, cool. Let's do one more of the same type. This time we have all sides. So this is a side, side, side. So let's call this A, B, C, and 7, and 13, and 8. And we have a different formula for side, side, side. Right? We had that double formula where we had to find the semi-perimeter first and then plug it into the area formula. So first the semi-perimeter. Note that you could find the missing angle and do the same thing we just did, right? But you notice it was kind of long. So if we have a more efficient method, we want to use that. So semi-perimeter, which is half the perimeter. So 7, 13, which is 20. 20 plus 8 is 28, all divided by 2. 28 over 2 is 14. And then we have our area formula. Right? That's going to be the square root and it's going to be 14 times 14 minus the first value times 14 minus the second value times 14 minus the third value. I'm just putting each of these in here in any order, it does not matter. Alright, so we have square root 14 times 7 times 6 times 1. And let's just go to the approximation from here. So square root of 14 times 7 times 6. It's 14 root 3, 24.2. Is the area, and we're dealing with inches here, so that's going to be square inches. Alright, so those are our two area problems. And lastly, we just have a little bit of word problems using some right triangle geometry, meaning we can use SOHCAHTOA and Pythagorean theorem. So these are all, we can assume these all create right triangles, such as a ladder leaning against a wall, like this would be the wall right here. And we can assume a wall is at perpendicular with the ground, like every single building has a perpendicular wall, not a wall at a slant. Right? And this particular ladder, there's my little ladder. Alright, it's 6 feet from the bottom, right? So I know this is 6 feet down here. And it is 15 feet tall. Right? And it's asking, what is the angle the ladder makes with the wall? So here's the ladder, here's the wall, so it's asking for this angle right here at the top. Right? Angle of depression, if you want to think about it that way. So I'm going to use, since I have some rise and run, I'm going to use some tangent. So tangent of my angle, let's call it angle A, is going to equal opposite 6 over 15. Right? Which means the measure of angle A equals the arctangent. We're finding an angle, right? So I have to use arctangent. And then we put that in the calculator. Arctan of 6 over 15. 21.8. There we go. And I think it says around to the nearest minute. Alright, so we're back to doing that. That's 21.8 degrees, which is going to be the same as 21 degrees and 80% of, and that 80% keeps coming up. That'll be 48. Yeah. .48 minutes. Okay. So that, and that's our final answer. Found our angle. Okay. So just a few more of these. Here we got Eddie and Dustin, and they're staring at a bat in the sky. Right, way up here. Alright. So we have, that's 24 degrees, and this is 43 degrees, and we know they're 100 feet apart, right? And we're trying to find, as our answer, find the height of the bat above ground. Okay, so we're trying to find what this value is. All right, that's our final answers, whatever this is. Now note that we can't just break this into two right triangles and say this is 50 and this is 50, because these are, it's not isosceles, right? These are not the same, so it's not going to be a 50-50, which means I need to find the length of one of these two sides here, right? Then I can do a little trig to find out, one or the other. I only need to do on one of them. Alright, so let's see here. First of all, I need to do, if I was going to use I could use law of cosines. I got two sides, side angle sides. I can use law of cosines to find this. That would work fine. So let's do that. I'm going to find A, and we're going to do 180 minus 24 minus 43. Alright, and that will give us, let's see here, 24 minus 43, 113. So now we know A is, this is 113 degrees. Right, so I can use either one of these triangles right now, right? And with the law of sines, and that can help us find a missing side here. So next, let's do that. Find the missing side. Go to green, and I can use sine of 113 and 100. And it doesn't matter which one you pick. You got to pick one. So let's do, how about 43. So let's do sine of 43. Alright, we'll call this B. So that's side B right here. So B is going to equal 100 times sine of 43 divided by the sine of 113. So 100 times sine 43 over sine 113. We get 74.1. Alright, so we know B is 74.1. And now we can use only just one right triangle. We can use just this right triangle here, right, to help us find H. Right, and it's kind of like we did on the last area problem. We're just going to do sine of 24 equals H over 74. So sine of 24 equals H over 74.1, which means H will equal 74.1 times the sine of 24, which is going to be approximately, see, 74.1 times sine 24, 30.1. And we're dealing with feet, so let's get units on there. This is 30.1, and that's our answer. Alright, last problem. Find the height of the shadow cast by 10-foot lamppost. So the lamp is 10 feet tall, and we want to find the cast of the shadow, which would be down here. I can call this S for shadow, and it says the angle of elevation is 58. So we'll say this is 58. And we're trying to find, again, just the base here, or in this case, yeah, just the base. So this is actually a very straightforward, actually geometry, very basic geometry question. We have the rise, we're asked to find the run, and we have an angle. So we'll use tangent, opposite over adjacent. So we get tangent of 58, right, equals (10 over S). Right, so that means S, the shadow, will be 10 divided by tangent of 58. Remember, if our variable's on the bottom here, we just swap those two. It's the same as multiplying both sides by S and then dividing both sides by tangent 58, and effectively just switches the positions of both. Alright, so our shadow is going to be 10 divided by, 10 over tangent of 58, which is about 6.2. And we're dealing with feet again, so let's get the feet on there. All right, and there is our final answer of 6.2 feet. All right, so that concludes it. Now, make sure you can do each of these problems by yourself with no help, right? Make sure you wrote out all the work that explains to get your answers. You have to, write your thinking down. So, since we're using the calculator a lot, remember the step before your final answer should be exactly what is put in the calculator. So whatever I put right here, right before my answer, should match exactly what's in your calculator. Right? So we can recreate anything that we might need to. All right. So good luck, and I'm sure you're going to do great.